Okay, hi everyone. In this video, I'll be going through the Sec 3A Math Chapter 4 on polynomials and partial fractions, and we will be looking at worksheet 4, which is touching on the topic of partial fractions. Okay, so in this worksheet, you should learn how to identify whether a fraction is a proper or improper fraction, how do you turn an algebraic fraction into its partial fractions, and therefore then work out a steps to turn an improper fraction or proper fraction into its partial fractions. So let's start by first understanding whenever I have two different polynomials, let's say fx and gx, and whereby your gx is not zero, and I divide them, let's say fx divided by gx, this expression here is called an algebraic fraction. Okay, so we'll first learn by identifying what exactly is a proper or improper fraction. So the definition is that if the degree of the numerator is less than, note this is a strictly less than, so if I were to write this as an inequality, this is strictly less than, okay, if the degree is a number of the numerator is less than the degree of the denominator, then the fraction is called a proper fraction. Otherwise, it is considered an improper fraction. So let's illustrate this using the following activity. So I hope you still remember what is the meaning of degree. So let's look at part 1. If I have this algebraic fraction over here, we consider the numerator first. The degree of the numerator is the highest power of x, which in this case it's 2. So if I have to label this, the degree of the numerator is equal to 2. Whereas for the degree of the denominator, if I were to look at this denominator here, the highest power of x is 1. So the degree of the denominator is equal to 1. So we go back to the definition now. If the degree of the numerator is less than the degree of the denominator, it is a proper fraction. Otherwise, it is an improper fraction. So over here, the numerator degree is 2, denominator degree is 1. So the numerator degree is more than the degree of the denominator. Therefore, for part 1, this is an improper fraction. Okay, let's look at part 2 now. Let's look at part 2. If I were to look at this fraction over here, okay, this is my numerator. If I were to expand out these two brackets, I will get the x term, which is the highest power of x, would be equals to 2, because this x will be multiplied to this x over here. So over here for the numerator, even though it's expressed as a product of linear factors, okay, over here, the degree of the numerator is equal to 2, because when I expand out, the highest power of x is 2. And you can see clearly for the denominator here, the degree of the denominator is equal to 2. Okay, so I go back to the definition again. If the degree of numerator is less than degree of denominator, it is a proper fraction. Over here, the numerator and denominator degree is the same. It is not less than, so part 2 is still an improper fraction. Okay, let's look at part 3 now. Part 3, I have this fraction over here. I identify from my numerator, the degree is equal to 2. Whereas for the denominator, if I were to analyze this fraction here, if I were to expand out this denominator, I will get x, the highest power of x will be equals to 3, x cubed. So the degree of my denominator in part 3 is equal to 3. Okay, so therefore, I analyze again. I notice that the degree of the numerator now is less than the degree of the denominator. Therefore, part 3 is a proper fraction. Okay, and for the last part now, let's look at the numerator. The numerator degree is, you can see directly that this is equal to 5. The denominator degree, if I were to expand out, I will get x power 4 plus 2x cubed. The highest power of x is 4. So therefore, the degree of the denominator here is equal to 4. Okay, so I have to analyze again. The degree of my numerator is more than the degree of the denominator. Therefore, it is not a proper fraction. This is an improper fraction. Okay, so I hope through this activity you can very importantly know how do I identify if a fraction is a proper or improper fraction, because this will be an important step to complete this worksheet. Okay, let's move on now. Okay, so now we're going to look at this thing called partial fraction decomposition. So if you remember what you have learned in Sec 2, in Sec 2, you have learned how do I add two fractions together. We remember that we must make sure that the denominator is the same. So you can do so by multiplying the other denominator to the various fractions in order to make them to have the same denominator before you can add or subtract fractions. So in A Math for Sec 3, you will now learn how do I reverse this process. Taking a fraction like this, how do I break it into different two parts over here? Okay, so over here, why do we call this chapter partial fraction is because I'm turning one fraction, I'm breaking it into two parts. This is part 1 and part 2 of this fraction. Therefore, we call this whole topic partial fractions, breaking down one large algebraic fraction into different parts. Okay, so over here, there are some steps which you'll need to learn and follow in order to break down one fraction into the sum of its partial fractions. So let me quickly run through the steps first, then we'll illustrate this through an example. To express a fraction as a sum of its partial fractions, we must follow these same steps. Step 1, we check if the fraction is a proper or improper fraction. If it's improper, we have to use the division algorithm to express the fraction as the sum of a proper fraction and a polynomial. Okay. Step 2, for proper algebraic fraction, once I see that the fraction is an proper algebraic fraction, we will factorize the denominator first, then apply the following rules in this table to perform the decomposition. So if the denominator has a linear factor, linear meaning x, the power of x is 1, I can decompose the linear factor and rewrite it as a partial fraction with the same linear denominator. Okay, if the denominator is a repeated linear factor, which means a linear factor square, I can decompose that into a over the ax plus b as linear factor plus b over ax plus b squared. Please take note that a and b are just constants which we will need to find. We have to find out what is the value of a and b. Okay, and if the denominator is an irreducible quadratic factor, let's say x squared plus c squared, which means irreducible means cannot be factorized, then I'll write the partial fraction as ax plus b over the irreducible linear factor. Okay, so this might be confusing to you, so let's illustrate this through example 1. So after step 2, once we have broken down the fraction into its partial fractions, then after that you substitute values of x and find the values of a and b respectively. Okay, so let's illustrate this through example 1 so you can better understand what these steps mean. Okay, so example 1, I have this fraction over here. The question says express this in partial fractions. So before that, I have an acronym which could help you remember the steps. Okay, one easy way to remember the steps, if you can look at this picture, right? This is a picture of these eyes seeing this flash moving very fast. So the acronym that you can remember is called CFAST. Okay, what does it mean? C stands for check proper or improper fraction, factorize denominator, assign partial fractions based on the rules in the table, solve for a, b, and c, your unknown constants, and last step, tie everything together and write out your final statement. Okay, so hopefully this is a way which can help you remember the steps in case you find it hard to remember the steps you have to follow to break down something into its partial fractions. So let's look at example 1. Example 1, okay, let me write down the steps here. See fast. Okay. Step 1, express something as its partial fraction. Step 1 is check. Check whether proper or improper fraction. So how do I check first? I look at my fraction over here. Okay, I notice that the numerator, the degree is 1. The denominator, the degree is 2. So therefore, I've checked that this is a proper fraction because the degree of the numerator is less than the degree of the denominator. So therefore, over here we can write that, note that 16x minus 28, this whole thing divided by x squared plus 2x minus 3 is a proper fraction. Okay. If it's a proper fraction, I don't need to do anything. Okay, so but if it's an improper fraction, I have to use my division algorithm to get a proper fraction out. So over here, this is a proper fraction. So step 1 done, check that it's a proper fraction. Step 2 now, we factorize. F stands for factorize. Factorize what? Factorize the denominator. So over here, I know that 16x minus 28 over x squared plus 2x plus minus 3. I can factorize my denominator. So I hope that you know how to quickly factorize this. X squared plus 2x minus 3 can be factorized into, I should get x plus 3 times x minus 1. Okay, so once I factorize this, now my next step is to assign. A stands for assign partial fractions. So what does it mean by assigning? This means that now I'll write let 16x minus 28 over x plus 3 times x minus 1 be equals to its assigned partial fraction. So I look at the denominator here. I have two linear factors. So therefore, if it's a linear factor, I go back to the table. Linear factor, I'll write my partial fraction to be an unknown constant over the linear factor. So over here, since I have two linear factors, I will turn this into a over, first linear factor is x plus 3 plus b. B is another unknown constant over x minus 1. And therefore, you define over here, since I introduce a and b, where a and b are constants. Okay. So done. This is assigned partial fractions done. We have assigned this correctly. Next step is to solve. S stands for solve. Solve for what? We solve for A and B. So over here, how do I solve this equation here? What I need to do is simply first, I get rid of the fractions. How do I get rid of the fractions? Over here, I can multiply this entire equation by this denominator here. If I multiply this x plus 3 times x minus 1 to the entire equation, my left side, the denominator will completely disappear because I multiply everything by x plus 3 times x minus 1. So let's put this into words. I write down clearly. Multiply equation, the entire equation by x plus 3 times x minus 1. So therefore, my left side now will just become 16x minus 28. Then now for the right side, I will multiply each term by this thing over here. So meaning this first term here, when I multiply by x plus 3 times x minus 1, the x plus 3 will cancel out. I'll be left with a times x minus 1. Then for the second term, plus b over x minus 1, if I multiply it by this x minus 1 will cancel out. I'll be left with plus b times x minus x plus 3. Okay, so from here, now I want to find out what is my a and b. So over here, wait, let me minimize this so that I can write more things. Okay, okay, so over here, now this is a polynomial identity which we have learned in worksheet 1. How do I find the values of a and b from here? Okay, note that as this identity, this identity will satisfy any value of x. So you can choose any value of x to sub in order to find a and b. So if you think very smartly, how do you think I can find the value of a? It means I must get rid of b, right? So what value of x can you sub in such that you can get rid of this b over here? Then I can just find out a. Since I have a x plus 3, if you are sharp, you can see that if I sub in x equals to negative 3, this b will be b times 0, this b will disappear. So that is what I can do. I'll sub x equals to negative 3. Okay, so over here, 16 times negative 3 minus 28 equals to a, negative 3 minus 1, then the b will disappear. Because this is Negative 3 plus 3 is 0. B times 0 is 0. So this thing will become 0. So I don't need to write it over here. Okay. Then now I'll get 16 times negative 3 minus 28. I should get, let me use my, okay, so 16 times negative 3. You can write down over here. 16 times negative 3. I'll get negative 48 minus 28 equals to negative 3 minus 1 is negative 4a. Okay, so therefore negative 4a is equal to negative 76. A is simply equals to negative 76 divided by 4, which will be 19. Okay, this is for finding A. Now I can also find the value of B. How do I find value of B? We use the same steps. What value of x can you sub in order to get rid of this A over here? And you realize that I can sub in x goes to 1. Because if I put 1 minus 1, this whole thing will become 0. So what I can do is that I'll sub x equals to 1. Then my left side, 16 times 1 minus 28 will be equals to, this A will disappear because it's A times 0, which is 0. I will get B times 1 plus 3. So over here, I will get simply 4b, on the right side is 4b equals to 16 minus 28. Okay, which will be negative 12. Therefore, b is equal to negative 3. Okay, so now solving part, I have now done this part of solving for A and B. Last step, T. See fast. T stands for tie together everything. What does tie together everything mean? Now that I found A and B, and I must now represent my answer using the final statement. They say the question is express this fraction in its partial fraction. So I found the value of A and B over here. Therefore, final answer to this question, you must state this final answer statement. Therefore, 16x minus 28 over x plus 3 times x minus 1 is equal to 19 over x plus 3. Then b is negative 3, so this will be minus 3 over x minus 1. Okay, and that is your final answer to example 1. Okay. Okay, so if you are okay, you can now try example 2 by yourself. The steps are the same. Okay, so over here, let's look at example 2. Now remember this acronym to help you remember the steps to solving this type of questions. See fast. Okay. Let's look at example 2 now. Example 2, express this in its partial fractions. So over here, example 2, we can write all the steps again so it helps you remember. See fast. Okay. C stands for check. Check whether it's improper or proper fraction. So I look at this fraction again. The numerator degree is 2. Denominator, the degree, if you were to expand out everything, you'll notice that the degree here of the denominator is 3. Okay, the highest power of x will be equal to 3 if I were to expand out everything. So therefore, I can write that. Note that this fraction, 9x squared plus x plus 7 over 2x plus 1 times x minus 2 squared is a proper fraction. Because the degree of the numerator is less than the degree of the denominator. Okay, so now next step. After I check already, next step is factorize. Factorize, I check the denominator. It is already factorized. So step 2 is done. Next step, assign. Assign what? Assign partial fractions. So now I check the denominator. So I will write let 9x squared plus x plus 7 over 2x plus 1 times x minus 2 the whole thing square be equals to, then now I assign the partial fraction by looking at the denominator. Here I have one linear factor. So based on this linear factor, I'll get a over 2x plus 1. Next one, if I look at this thing here, x minus 2 the whole thing square. this is a repeated linear factor. So if you go back to your table over here, the table says if I have a repeated linear factor, you will turn this thing into, the partial fractions will be written in this form. So now, for this part here, the repeated linear factor, I'll use two other unknown constants, b over x minus 2 plus c over x minus 2 the whole thing square. Okay, then therefore from here, we have done part 3, which is assigning the linear factors, the partial fractions, where a, b, and c are constants. Okay, then from here, next step, solve. How do I solve this? So over here, the steps are the same. First, I get rid of the fractions by multiplying this denominator here throughout the entire fraction. So over here, I'll write as a working, multiply throughout by 2x plus 1 times x minus 2 the whole thing squared. Okay, so if I multiply throughout, now my fraction will turn into, this left side here will no longer have a fraction. The entire denominator will cancel out. With this thing here, I will get 9x squared plus x plus 7. Then now, to each term, I'll multiply this expression here. So for this first term here, by multiplying this expression, 2x plus 1 will cancel out. I'll be left with a times x minus 2 the whole thing squared. Okay, next one, second term. This term here multiplied throughout by this, I'll be left with plus b times, here one of the x minus 2 factors will cancel out. So I'll be left with 2x plus 1 times x minus 2. Then for the last term here, multiplying by this, the entire x minus 2 square will cancel out. I'll be left with plus c times 2x plus 1. Okay, so once I've done that, now I've obtained this polynomial identity over here. My next step is to simply figure out what values of x can I sub into this identity here to find the values of a, b, and c. Okay, so by analyzing, you can see that, how do I find the value of, let's say if I have this bracket over here, x minus 2, right? If I sub in x equals to 2, this whole x minus 2 will become 0. This thing will become 0. So that means if I sub in x equals to 2, your a will disappear, your b will disappear, I'm left with only c. So that's one way I can do to find the value of c straight away. So I'll sub x equals to 2. Then I'll get 9 times 2 square plus 2 plus 7 equals to, then we notice that if I sub x equals 2 here, this will be 2 minus 2, which will become 0. This thing will cancel out. Next term, x minus 2 here will become 0. B will also cancel out. I'm left with c. Okay, so this will become plus c times 2 is 4 plus 1. Okay. Therefore, by simplifying from here, I will get 36 plus 9, which will be 45, equals to 5c. C will be equals to 9. Okay, this is to find the value of c. Next one, what can I sub in? If I have another factor which is 2x plus 1, what value of x can you sub in to make this be equal to 0? I hope you are sharp enough to see that if I sub in x equals to negative half, this will become negative 1 plus 1, which will become 0. So therefore, next value I can choose, sub x equals to negative half. Okay, so over here this means that 9 times negative half square minus half plus 7 will be equals to, here I notice if I sub negative half, this thing will become 0, this thing will become 0, that means my b and c will cancel out, I'm only left with a. So this will become a times negative half minus 2 the whole thing square. Okay, so therefore over here, by simplifying, I will get, let's say, this will become 9 over 4 minus half plus 7 equals to a negative half minus 2. This will be negative 5 over 2 square. Okay, then by further simplifying, I will get, this will be 25 over 4a will be equals to 9 over 4 plus 7 minus half will become 7 over 4. 7 over 4 plus 7. Okay, so 25 over 4a will be equals to 35 over 4. Okay, so therefore over here, by simplifying, a will be equals to 35 over 4 divided by 25 over 4. I'll get 7 over 5. Okay, and with that, I found the value of a and c from here. Then if you were to observe this identity again, you'll note that there's no other values of x I can choose to sub in to cancel out x minus 2 or 2x plus 1. So your last step is to simply choose any x answer that you can sub in to find the value of c. Since I found the value of c and a already, so I want to find the value of b from now. Okay, so very easy number to choose. Just choose, let's say x equals to 0. Because this one will cancel out my 9 times 0 is 0. This will become 0. It will become very easy to use. So over here, I will sub x be equals to 0. Then I'll get, my left side will just be, I'll sub 0, I'm just left with 7. So 7 will be equals to a. And I know that since I know that a is 7 over 5, I can now sub in 7 over 5 times 0 minus 2 square, which is minus 2 square, plus b is the unknown here, times 2x plus 1, which is just simply times 1, then 0 minus 2x is minus 2. So this is times 1 times negative 2. Then the last one, sub in 0, is c times 1, which is simply plus c, which is plus 9. Okay, so therefore if I were to simplify, I'll get, what do I get? I'll get 2b will be equals to 28 over 5 plus 9 minus 7. Okay, so you just press this in your calculator. You should get the final answer here. B should be equals to 19 over 5. Okay, so therefore now that I found the value of a, b, and c respectively, very simply I can now simplify from here. Make this smaller. So therefore, I found the values of a, b, and c. So that means the solving part is done. Last step is to tie everything together, which means that I will rewrite this answer now. Therefore, 9x squared plus x plus 7, the whole thing over 2x plus 1 times x minus 2 squared is equal to, so a is 7 over 5, but take note, I shouldn't write, since a is 7 over 5, I shouldn't write this as 7 over 5 like this. This 5 will go down to will be multiplied to the denominator. So this can be written as, for part A, 7 over 5 times 2x plus 1. Same thing for B. B is 19 over 5, which is equivalent to 19 over 5 times x minus 2. Then the last one, C is 9. So this will be plus 9 over x minus 2 the whole thing square. Okay, and that is the answer for example 2. Okay, let's move on to example 3 now. Example 3, express this in partial fractions. So the steps are the same throughout. So I'm just going to write the steps over here. C fast. Okay, please try this example by yourself. The steps are exactly the same. You need to just identify clearly. Okay, so you can pause this video here first. Then after that, once you are done, you can continue playing this video to see how I work through these steps. Okay, so let's continue from here. How do I solve this question over here? So first step is to check whether this is a proper or improper fraction. So by checking, I hope you can see clearly that over here, example 3, numerator is degree 1, denominator is degree 3. So therefore I can make the conclusion that note 7x plus 2 over x squared plus 4 times x minus 2 is a proper fraction. Okay. Then next step is to F stands for factorize. Factorize denominator, I check, can this denominator be factorized any further? Some of you might be tricked. X squared plus 4 is not the same as x squared minus 4. This cannot turn into x plus 2 or times x minus 2. This is only for x squared minus 4. So if you were to turn this into this factorized form, this is wrong. Please do not get tricked. Okay, x squared plus 4 cannot be factorized any further. Okay, so factorized part done, check. Next step, assign. What does assigning mean? It means that over here, since I factorized the denominator fully, I'll let this fraction 7x plus 2 over x squared plus 4 times x minus 2 be equals to its partial fractions. So I check this denominator here. X squared plus 4 is a irreducible quadratic factor because I cannot factorize this any further. So if I go back to my table, over here, irreducible quadratic factor, I'll turn this into the irreducible quadratic factor by itself. So very simply for example 3, this will turn into, first one, ax plus b over the irreducible quadratic factor x squared plus 4. Then the next factor is a linear factor x minus 2. So this will be plus c over x minus 2. Okay. Then now my next step, once I've done that, we also need to label because I introduced A, B, and C, where A, B, and C are constants. Okay. So assigning part done. Next step, solve. Solve for A, B, and C. So remember the first step is to get rid of the fraction here by multiplying throughout by this denominator over here. So over here, I'll write multiply throughout by this factor x squared plus 4 times x minus 2. Okay, then I will get over here, the left side, the fraction will disappear. I'll get 7x plus 2 equals to, take note, this ax plus b multiplying to this whole thing here, this denominator here will cancel out. I'll be left with bracket, very important because it's the entire numerator, ax plus b multiplied to x minus 2, then plus this second term here multiplied to this whole thing, x minus 2 will cancel out. It will become c times x squared plus 4. Okay, so the steps are the same now. Find values of x to sub in to find your a, b, and c. So I hope you can see clearly over here. To find c, I just need to sub in x equals to 2 to turn this into 0, and this whole thing will disappear. Okay, so over here, step 1, sub x equals to 2. I'll get 14 plus 2 equals to c times 2 squared is 4 plus 4. So therefore, 8c is equal to 16. C equals to 2. Okay, next one. Now I know the value of c. How do I find a and b? You can sub in x equals to 0 to get rid of a. Then I can find b easily. So over here, sub x equals to 0, I'll get 2 equals to b times negative 2 plus 2 times 4. So over here, 2b will be equals to 8 minus 2, which is 6. B will be equals to 3. Okay. And the last one, I can choose any x value since I already use numbers and can cancel out. x squared plus 4, I cannot use any numbers to cancel out this factor here. So just choose any numbers very easily. Let's say if I choose x equals to 1. Okay, left side will become 7 plus 2 will be equals to a times x is a plus 3 times 1 minus 2, which is negative 1, plus c, which is 2, times 1 square, which is 1, plus 4, which is 5. Okay, I'll get 9 be equals to negative a minus 3 plus 10. So a will be equals to 7 minus 9 and equals to negative 2. So therefore, final answer to this question. Okay, solving done. Last step, tie together. So therefore, now I found the values of a and b and c. My final answer statement, therefore, 7x plus 2 over x squared plus 4 times x minus 2 is equal to negative 2x plus 3 over x squared plus 4 then plus 2 over x minus 2. Okay, so with that, I've tied everything together and decomposed this into its partial fractions. Okay. Okay, let's look at example 4 now. Let me minimize this. Okay, so if you are fast, you can now try example 4 by yourself before and then pause this video. Then once you're done, you can continue playing this video in order to see the work solutions to example 4. Okay. Okay, so now let's look at example 4. Okay, example 4 over here. Okay, let me write down the steps again. I have C fast. Okay, so steps are the same throughout. Step 1, we check whether this is a proper or improper fraction. So let's look at this over here. I want to express this into its partial fractions. So check. I note that degree of my numerator is 3, degree of denominator is 2. This is now an improper fraction. So I cannot move on to the next step yet. So now I note that this is an improper fraction. 9x cubed plus 4x plus 3. This whole thing divided by x squared minus 1 is an improper fraction. So what do I need to do now? I need to use my long division in order to turn this into to get a proper fraction. So let's use our long division. I hope you still remember how to use long division. I'm dividing this numerator. This is my divisor. So if by long division I can write x squared minus 1. Okay, this is my divisor. I'm dividing 9x cubed plus, because there's a missing x squared, I'll leave a space, plus 4x plus 3. Okay, so by long division, I note that in order to get 9x cubed, I'll multiply on 9x. This will become 9x cubed. Then this 9x multiplied to this entire divisor here. I'll get minus 9x. Okay, then now I subtract the entire thing. So this will be 4x minus negative 9x, which will give me 13x plus 3. So therefore, I can now rewrite this 9x cubed plus 4x plus 3 over x squared minus 1. This can be rewritten into the quotient here, 9x plus 13x, the remainder, divided by the divisor, which is x squared plus 1. Okay, x squared minus 1. Okay, so let me highlight this first. 9x here is the quotient. The quotient here will be written as this separate term here. The divisor, x squared minus 1, okay, can be found here. And the remainder, 13x plus 3 will go over here. So some of you may wonder, how do I actually obtain this thing over here? So actually, if we were to go back to what we have learned in the division under worksheet 3, or is it 2, under how to use the division algorithm, or is worksheet 1. Okay, let me draw this out separately. Remember, if I were to divide a polynomial by, I can rewrite, if I, let's say, if I have fx here, I want to divide fx by a divisor gx. It can be rewritten as gx times a quotient plus a remainder. Okay, and this is my divisor. This is the polynomial you're dividing this by the divisor over here. So how do I get this partial fractions form? Is essentially, if I divide this whole equation by gx, I rewrite this. Now fx is the polynomial. I divide it by the divisor gx. I will get the quotient qx plus the remainder over gx, which is the divisor. I'm dividing both sides by the divisor gx. Okay, so this is how I obtain this form over here. This fraction, I'm dividing this polynomial here fx by a divisor here x squared minus 1, which is fx here divided by this gx, which is my divisor over here. And therefore, the quotient can be written as 9x, quotient over here, and this fraction will turn into the remainder divided by the divisor, which is the remainder here divided by the divisor. So I hope you can see, when I have an improper fraction, how do I convert and obtain a proper fraction using the long division method. Okay, so let me box this out so that it's clear for you to understand how we obtain this form over here. Okay, great. So now, step 1, I have checked, and now I have obtained a proper fraction, which is, this is now the proper fraction. Okay, now using this proper fraction over here, I will now, next step, factorize. Let me use different, factorize. Okay, step 2, factorize, meaning now I consider just this proper fraction over here. Okay, 13x plus 3 over x squared minus 1. We note that, consider this proper fraction first by itself. 13x minus plus 3 over x squared minus 1. Check denominator, can I factorize this further? X squared minus 1 can be rewritten as 13x plus 3 over, remember your special identity, x plus 1 times x minus 1. Okay, so over here, part factorize part done. Next step, assign. Remember, what does assigning mean? It means that based on my proper fraction, I want to break this into its partial fractions. So I'll let 13x minus 3 over x plus 1 times x minus 1 be equals to its partial fractions. Based on the denominator here, these are two linear factors. So this will turn into a over x plus 1 plus b over x minus 1. And don't forget to define where a and b are constants. Okay, so assigning part done. Next step is to solve. So solve for a and b. So the steps are the same. Multiply throughout this whole equation here by this denominator here. I will get 13x minus 3 equals to a. This first term multiplied by this denominator, x plus 1 will cancel out. I'll be left with x minus 1 plus b times x plus 1. Okay. Then from here, the steps are pretty straightforward. So let me minimize this so I got more space. Okay, so over here, the identities, the steps are the same. Find a and b. Hope you can see that what values of x can I sub in to find a and b respectively. I will choose sub x equals to 1. I will get 13 minus 3 equals to, the a will disappear, b times 2. So therefore, 2b equals to 10, b equals to 5. If I sub x equals to negative 1. Negative 13 minus 3 will equals to a times negative 2. The b will disappear. A will be simply equals to, over here, a will be equals to 8. So therefore, I found the values of a and b. Now, final answer to this question. Remember, the original fraction is 9x cubed plus 4x plus 3 equals to this. I've used the partial fraction decomposition to break this into its partial fractions. Therefore, final answer is simply 9x cubed plus 4x plus 3. Let me write down tie together. Okay, tie together meaning this thing over here over x squared minus 1 be equals to, don't forget about this 9x. If you forget this, you'll lose marks for no reason. Okay, 9x, then plus this fraction here, I've broken it down into this part here, and I found the values of a and b. So I'll get 8 over x plus 1 plus b. B is 5 over x minus 1. Did I break it down correctly? A equals to x minus 1. Okay, and that should be the answer for this part over here. Okay, 13x. Wait, did I make a careless mistake? Wait, sorry, I think this one should be, I wrote this to be 13x minus 3. Sorry, this one should be plus 3. Careless mistake here. So this one should be plus 3 plus 3. Then your answer will roughly change. 13x plus 3, this will be 8. Okay, and this will be 13x plus 3. This, your a should be negative 10, 5. Okay, so therefore, just a small correction. Your b is 8, a is 5. So therefore, over here, your final answer should be 9x plus 5 over x plus 1 plus 8 over x minus 1. Okay, and that's your final answer to example 4. Okay. Okay, then now let's look at the last question, last example for this worksheet, example 5. Okay, for example 5, this prism has a volume of this. You can try this by yourself first. Then you can pause the video. Then if okay, then you can play this video to see the answer. Okay, so for example 5, prism has a volume of this. Take note, this question requires you to remember the formula of a prism. Okay, so let me just write down over here, volume of prism. The formula, what you should have learned in lower sec is that is equal to cross-sectional area times height. Okay, so for part 1, find the expression for the height of the prism. Height is simply volume divided by cross-sectional area. So over here, let's call the height. Let h be the height of prism. Height of prism. Okay, so over here, h will be equals to 3x squared plus 8x plus 1 over the cross-sectional area, which is x squared plus 2x plus 1. Okay, so now this is part 1. Part 1 done. Now part 2. Okay, part 2, express the height found in part 1 in partial fractions. So now let's write out the steps again. I know the steps are C fast. Okay, step 1, check for improper or proper fraction. So if I were to look at this fraction over here, I know that the degree of the numerator is 2, degree of denominator is equal to 2. Since the degree is the same, this is an improper fraction. So note, okay, this fraction here is an improper fraction. Okay, is an improper fraction. So that means that I have to use my long division now. I'm dividing 3x squared plus 8x plus 1 by the divisor x squared plus 2x plus 1. So over here, by long division, I will multiply a 3 in order to turn x squared into 3x squared. Multiply a 3, write down, bring this down a bit. Okay, then this will become 3x squared, then this 3 multiplied to the entire divisor, plus 6x plus 3. Okay, now I subtract the whole thing. I will be left with 8x minus 6x is 2x minus 2. Okay, therefore I can rewrite this. Therefore, 3x squared plus 8x plus 1, it can turn into this whole thing over x squared plus 2x plus 1 can be rewritten into the quotient 3 plus remainder 2x minus 2 over the divisor x squared plus 2x plus 1. Okay, then check proper fraction, done. Next step, factorize. Factorize the denominator. I note that x squared plus 2x plus 1 can actually be factorized into 3 plus 2x minus 2. This is a special identity if you can recognize. This is simply x plus 1 the whole thing squared. Okay, so next step, factorize, done. Next step, assign partial fractions. So I just consider this fraction by itself here first. Okay, next step, what I'll do is that I'll let 2x minus 2 over x plus 1 the whole thing square be equals to, remember your repeated linear factor, the partial fraction form is a over x plus 1 plus b over x plus 1 squared. Okay, where a and b are constants. Okay, so over here, recap again, what do we do next? Next step is I will get rid of these fractions by multiplying this denominator here throughout. I'll get 2x minus 2. First term, multiply by x plus 1 square, I'll be left with a times x plus 1. Then second term, multiply by x plus 1 square, I'll get plus b. Okay, then from here, okay, let me make this smaller a bit. Okay, so take note over here, once I've assigned now on my next step, which is to solve for a and b. So over here, how do I get rid of this a? I can sub in x goes to negative 1. Sub x goes to negative 1. I'll get negative 2 minus 2 equals to b. b is simply equals to negative 4. Okay, then next step, to find value of a, I can choose any other x value to sub in. Any easy and small number to use is simply, let's say, sub x equals to 0. This can be any number you want, but you will choose a number that's small and easy to use. So this will be negative 2 equals to a minus 4. A will be simply equals to 2. Okay, so therefore, final answer to this question, express the height in partial fractions. Therefore, the height h, which is given by this expression over here, will be broken down into here. And this fraction can be broken down into this part here, whereby I found the value of a and b. So final answer is simply equals to 3 plus 2 over x plus 1 plus b is negative 4, so this will be minus 4 over x plus 1 the whole thing squared. Okay, and that is it for the last example of this worksheet. Okay, so now that you have gone through this, you can now attend the practice questions by yourself, and that will be the end of this video.